Good day, ladies and gentlemen. Welcome to this session. This session will be more focusing on isometric drawings. Now remember, with your exam papers, any exam paper, you will have question 1 and question 4 that will be mechanical drawings. With question 1 it will be mechanical and analytical, and mechanical assembly with question 4. With question 2 there's a variation in paper 2 between cams, loci of helix and loci of mechanisms, but then question 3 will definitely be there as an isometric drawing. Right, so 1, 3 and 4 will always be fixed as those drawings. Then question 2 will be alternating between those topics. But now we're focusing on isometric drawings. I'd like to explain drawings, and obviously we need to go to the slideshow, so I can roll down to the slideshow and it will be much easier in doing so. Now with isometric drawings, if you take a look at that drawing itself, it forms part of paper 2. Isometric drawings is on where the object is standing on one single point and then turns out to be 30 degrees and 30 degrees to either side. It can be seen as three-dimensional drawings or pictorial drawings itself. You talk about, if this is a drawer, you talk about the width of the drawer, you talk about the height of the drawer, and then how deep you can put your hand in the drawer. It will be the depth of the drawer. So those are the dimensions we're talking about. And then of course it works out from 120 degrees, 120 degrees and 120 degrees. But in fact we're not working with 120 degrees, since we do have got a set square that will help us, and that set square is set on 30 degrees and 60 degrees, so we will be working on 30 degrees to either side, to the left and as well to the right hand side, right? And the height will be then obviously from that point upwards. There's your 30-60 degree set squares. I often see learners using their 45 degree set square in doing isometric drawings, which is totally wrong, right? You can't even get your marks with that because the position of the lines will be at the wrong place. So therefore, yes, you will lose a lot of marks. In fact, you won't be able to get proper marks if you use the wrong set squares in terms of that. All right, then also orthographic views will be given in third angle isographic projection. Since this is paper 2, third angle isographic projection is always prominent in this exam paper, so therefore the front view, left view and top view will be on that side. And then also we use the T-square as well as the set square in finding those lines, like the example I gave you just now, where you can see that the set square and the T-square slides the whole time to get lines parallel with each other. Of course, if the T-square slide onto the left hand side of your drawing board or the right, it doesn't matter. And if the set square is running on your T-square, it means that your lines will always be parallel. Obviously, you just need to measure accurate to get an accurate drawing in the process. Right. Hence, when doing drawings itself, it's very good advice to maybe draw a freehand drawing somewhere on your paper, very light or maybe on a loose piece of paper, just to help you to get the three-dimensional view of the specific drawing itself. All right. So that is always good advice in doing so. Where, let's say for instance, you draw a simple freehand sketch somewhere to find out how you're going to draw and how you attempt the drawing itself. All right, now just be careful, because if the examiner is not asking hidden detail, you don't need to show the back part. But in this case, it's the green lines, and we said the green lines will be type C lines, which is projection lines, which is soft enough so it doesn't bother us at all in the process. All right, so there we go, providing draw a left view for the left, if the left view is given to you, to the front view. In other words, in this case, you see that this is the front view, the top view is being placed on top, and then the left view will be placed to the left of the front view. Remember, it's third angle isographic projection. Look at it at the left and then turning back towards the left. Now, of course, if the left view has been given, then obviously it's good advice to start with the left view and the front view on the left hand side for the left view, simply because of the fact that it is much easier to interpret the drawing if some of the views are visible and you can put that view on the side of where the view is visible from. Alright, so therefore the left view is there, so I will start with the left view and then from there on the front view on that side to roll out the rest of the drawing. And the same with that, if a front view, a top view and a front view and a right view is given, then the right view will be placed on the right hand side, and then the front view will be placed on the left hand side over here. Alright, so that's my right view, so I will place my right view on the right hand side and roll it out from there further onwards to draw the rest of the drawing. Alright, so then start the isometric drawing from the base and build it up like Lego blocks, I used to say, from the bottom upwards. It will help you to a great extent in understanding the drawing instead of starting at the top and then try to go downwards. You will see why I'm saying so. There we go with the base, and from the base it goes upwards, and then you draw the rest of the drawing as you go further upwards itself. Then of course if there's more complicated blocks that needs to be paid attention to, then you can carry on with those blocks from the base upwards, so it's much easier to interpret in the process. Normally they don't ask hidden detail, but that can be asked if clarity is necessary, and all the hidden detail principles need to be applied at all times, going from solid lines to dash lines and all those type of things and so on. And then of course if there's no seam available or visible, you can here see there's no seam on this portion of the drawing itself where the block is pasted onto the other block. So it's a casting, it's casted into one huge casting itself. So no seams available, no solid lines will be drawn in those areas itself. Alright, then the principles, a few principles that I can point out to you. The question will be to convert the orthographic views to an isometric drawing. Now this is very entry level. I will show you some more advanced exercises just now. But yes, you have to use your T-square and your Z-square. So go from there upwards from that specific point, and then you have to draw the base, which is 80 millimeters. So you'll slide your Z-square and measure your 80 millimeters. On this side over here it's 40 millimeters. So I will slide my T-square in such a way, my Z-square in such a way to be able, or to enable me to draw the base of this part over here. So there we go with that portion of the block, and we said we build it from the bottom upwards. It's 20 millimeters high, so of course all these lines will also have to go 20 millimeters upwards. So at all times you are not allowed to work freehand. At all times you work with your T-square and Z-square, making sure and that all those lines will be parallel with each other, and to make sure that your drawing will be in good quality. So you can see over here these lines must be parallel. Of course those lines must be parallel, and if not, the marks will be subtracted in terms of that. Alright, so hidden detail, again, if it's necessary you have to put the hidden detail in. If there's a bit more to just this little block that you have to draw, like in this case there's two blocks at deeper in, obviously we're going to start on the bottom. You can in some sort of way try to visualize what will be on the bottom, what will be further upwards, and then from there on you don't draw all the lines dark from the start, simply because of the fact that there's some parts that will be hidden behind objects or areas of the object that will be placed. So those are the colors we've been working on. Please don't work with colors in your exam paper, just keep it straightforward and try to visualize what it is. Then you've got those little blocks on top. It's 20 millimeters in size and it's 10 millimeters high. So if I draw those blocks upwards from there, it means that I have to draw according to dimensions all those areas perfectly in, so to enable me to complete the blocks in a perfect way. So there we go with the upper parts, and then if I'm done with that part I can draw the upper parts or the vertical diagonal lines. There's of course the line there at the back that still needs to be drawn in, and also these lines that you see over here. So those lines at all times using your T-square and Z-square to complete the drawing, and there's the drawing completed. Alright, so of course again this is entry level. This is just small blocks on top of that part. We have to step up to a great extent, and like I say, you work from the bottom upwards to understand what is going on. You also bring into consideration whether it's a casting or whether those ends are pasted on at a later stage. If hidden detail is required, you have to put the hidden detail in. This is very important. You have to start with point S or point P or point Q, whatever the examiner is pointing out to you as the lowest point. The simple reason for that is, should you turn this block the other way around, where this gap over here is on the back, and I can't see that, obviously there's no part of that on the memo itself. The memo has been made up like this drawing over here, and you have to adhere to that to be able, or to enable you to get marks for this part over here. Alright, so obviously we'll start with the biggest possible block. It has got a gap over here for 30 millimeters and 10 millimeters inwards, so we can draw that part in over here. From this onwards I have to go upwards for 10 millimeters as the dimension is pointing out to me, and then from there on I can complete the upper parts, the bottom and then also the upper part, which is that part over there. Of course not drawing everything is in as dark lines. I've got a block at the back which is 15 millimeters high. I've got a block in front here which is 10 millimeters high, that you can see by the dimensions over here that's pointed out to you over there. And then from there on, this block will be represented by that block which is 20 wide, and then this block is 10 millimeters wide and 20 millimeters deep, if you see it that way, and 15 millimeters high. So you have to measure those blocks out once you are at that level, and once you're there you can extend it upwards. And the same with the block at the back. First measure it out, and then it has to go 15 millimeters higher, so therefore we go 15 upwards, and then the size of it will be completed on the top, which is that line at that end. So there's still ends that needs to be drawn in as dark lines, which is that line over there and this line over here, so we have to complete that for the complete drawing. Now if this line over here is soft enough, if you make use of a projection line, which is a type C line, it's not bothering and it will not be seen as a solid line or a seam, so therefore you can keep it. Please, if the examiner is asking to keep the auxiliary views and all those type of things, don't rub out the lines in terms of that. Okay, in this case, this is still grade 10 level that we're busy with. In this case, we have got no idea how high it is from there to there, because there's no dimension been given saying to you this is so high. Although it's standing on a slanted angle, on that diagonal line it's 20 millimeters, I still don't know what the distance is from there to there. It's going to be much shorter in terms of that. So we have to, by means of 60 degrees, work out what is that angle. Now we already work with 30 degrees, and it's basically impossible to work on 30 degrees and to determine 60 degrees on the 30 degrees. So in this case, we talk about non-isometric lines, in other words, isometric lines which is not either straight upwards or 30 degrees to the left or 30 degrees to the right. That means that we will have to work accordingly by saying, right, we have to find the angle, and then on that angle we can draw it in onto the part. All right, like I said, we work from the bottom to the top, so we go with the bottom base part. It is going 10 millimeters upwards, so therefore we're going to go 10 millimeters up on the front part. At the back part it's a bit higher. I'm not sure where and how far it has to go up there, but now we can complete this base part of it, and now we have to start with this back part over here. I don't know how high and how high it will be up to that point, so we have to start with an auxiliary view, and this is very important. With this you can't do without the auxiliary view. Once you're done with the auxiliary view, you know that 60 degrees and 60 degrees, and you know that diagonal distance is 20, but you don't know what the height is. So, and the distance between the two is 20, and that starts exactly in the middle, so we know it's going to be on that 80 millimeters. It's going to be starting at that point, 20 in total, so 10 to the left, 10 to the right to find the starting points. But now this, like I said, is 60 degrees and it's already standing on 30 degrees, so we can't do the calculations. Do the auxiliary view. Once you're done with the auxiliary view, you frame this drawing, and now you take the frame and you place this frame inside this area where it's supposed to be. In other words, if that is 20 from there to there, and I've got my frame over here, I can now measure the distance, total distance, either from the center outwards or the total length from this side to that side, and see it's maybe 44 millimeters or whatever the case might be. So I can go from the center 22 to the left, 22 to the right to determine this square block. Now this was 34 millimeters in this case. It's 12 millimeters, 18 millimeters high. So I can now take the square, or the rectangle in this case, take this rectangle and place this rectangle inside here in this area itself. Right, so 10 to the 20 to the front, take my rectangle, go 20 on either side, and then I'm going to start with this part. Remember, it's a clean area in the middle. And now the degrees of which I couldn't find, so now I'm going to measure 12 millimeters outwards, 12 millimeters outwards, or 34 divided by 2. So get those distances, go 18 upwards, and redraw, reconstruct this obscured rectangle in this area over here with the dimensions I've discovered just now for myself. Once it's there, once I've got these dimensions and points, I can plot those endpoints now, and I can basically join those endpoints with those ends to make sure that this is now, and this is the way I'm going to get my 60 degrees over here. But you can see that this angle is much sharper than that angle, so it's vertically impossible in determine this without the auxiliary view. So in most cases, when you find diagonal lines and no heights or no dimensions at all, then you should know that in this case I have to start with an auxiliary view, take the auxiliary view, reframe it into a rectangular like shape on the dimensions that you do have, and then start with that part over here. And then from there on you can complete the rest of the drawing by just simply join the lines and go 30 degrees outwards, and measure the distances of 20 millimeters. And then from there on, remember the depth is 20 millimeters, so all those lines going deeper in is 20 millimeters, and there we go with the complete part of this block over here. Most important, non-isometric lines, you have to keep the auxiliary view and you have to keep the frames that you've been using in determining those points over there. Without those, of course, you will lose your marks. The examiner is asking for those points and wants to see where those points come from, and then of course you will not get your marks if it's rubbed out afterwards. Alright, so there we go with the final figure. In this case over here, again we start with point S on the bottom. There's maybe point S, B, or Q, or whatever the case might be, should be there. There's a few things I want to point out to you. If it's 45 degrees and you've got a dimension, remember 45 degrees with a dimension will be also the same dimension length towards the other side. If it's 45, of course, if that is 30 degrees, it's not going to be the same dimension at both sides. But 45 will tell you. So if this is 20, I can make the conclusion that this will be 20, and that distance will also be 20 in the process. So I can start with my biggest possible block. It says 20 millimeters, so if I can measure my 20 millimeters up to there. If you're in doubt, you can still do your auxiliary view. Once you've got your auxiliary view, you can measure the distance. You will see it's 20 millimeters, so you can measure your 20 millimeters up there, and find those 20 millimeter points, and then complete the base part of this part over here. It's 10 millimeters high, so I'm going to go 10 millimeters upwards with this whole drawing. Now it has got some sort of pyramid there at the back, so if I complete this part over here, the pyramid will be placed on the right hand side over here. There you can see with the front view, it's on the right hand side. Now again, as far as possible, you'd like to save some time on drawing this drawing itself. So therefore it's 40, so it's 40 by 40 on either side, so it's 40 up there, 40 up there. This is also 40, so the block will start in this area over here. But the pyramid is 15 millimeters higher. Sorry for that. It's 15 millimeters higher. So that's what you see over there. I can now determine the biggest possible block. Let's say, for instance, I draw it up in this case. There we go with this front part over here. This is now 40 by 40 by 40 by 40. And I know that this is 15 millimeters higher. So with this 15 millimeters higher, I can go from the center point 15 upwards. Now, it's not necessary in this case for me to draw 15 upwards, 15 upwards, 15 upwards, and 15 upwards on this. So, and to draw the complete block on the top, it's going to waste a lot of time, and also to try to find the center point of it. I already got the center point. I know it's 15 high, so therefore I can just extend it upwards for that 15 millimeters, and then I can complete this from top to bottom up to that point, and that's basically what I need to determine. So off we go in this regard to find the pyramid of this specific drawing. Alright, so there we go. Now if we have to draw some circles, for drawing a circle, it's important that you at all times make sure that the biggest possible block will fit part in this circle itself. Again, I've got a front view and I've got my left view over here, so I'm going to use the left view. The left view is a narrow area of 40 millimeters. The front view will fit in over here. Now if you take a look at the side, from side to side, that is from there to that point is 70 millimeters. Top to bottom 70 millimeters. So I'm going to take 70 by 70 by 70 by 70 to draw this part in. So there we go with the biggest block. That's 70 millimeters. I'm going up 70 millimeters. I'm going to the right 70 millimeters, and to the top at that point also 70 millimeters. Of course with my T-square and set square. Saving time is because of the fact that I'm doing it in this way. Right, so once we're there, we can say the front view will fit into this area over here with a circle of diameter of 70, so 35 from center towards the side. So the front view circle should fit in at this specific point. All right, so the principle is now I'll go to the corners which is closest to each other, and that was those two corners. And from out those two corners, I'm going to the opposite line, the line's bisecting point. And I'll go from this corner to the opposite line bisecting point, and the same from this corner. The opposite line will be on that side over there, the bisecting point that I will find over there, the halfway mark in other words. And from this corner, it goes downwards towards that point. The opposite bisecting point will be halfway at that point. So therefore we go from this point outwards and from that point outwards. That gives us a shape that looks like this, for instance. Once I've got it there, I can now use those intersection points to set my compass to draw an arc over there. Of course, I can draw the rest of the circle, but it's unnecessary. I just need the outer part of it. So therefore, I'm going to use that part over there. I'm also going to use this intersection point, stretch it out up to that end point, and that will, if I work accurate, will stop at that point over there. So I'm going to draw an arc over here. And the same with this point over here. I've got already my intersection point. I can stretch open the compass up to that point and draw the arc up to there. And from that point, I can draw the arc, strike the arc from there up to that point over there. So there we go for the upper parts. That is for the outer, the larger circle. This, from this intersection point, it will be from that part to up to there, and then from that intersection point over there, it will form up to that point. And there's my circle, my isometric circle, as far as I can do it as accurate as possible. Now remember, you can't draw this freehand, simply because of the fact that it's compulsory for each EGD learner to have his compass. So therefore, those must be drawn by means of your compass. All right, the width or the depth of it is 40 millimeters. So I'm going to go from that edge over there 40 millimeters inwards, and from this edge over here I'm going to go 40 inwards. I've been using this intersection point to draw this arc over here. So I will be going 40 millimeters outwards using that intersection point, and then from there on I've used the circle compass to draw the circle, semicircle over here to that point. So I will use it from there up to there. At 40 millimeters later, I will use it to draw this part or this portion in. Now I think you can imagine if this goes 40 deeper in for the arc over here, the same will apply. I already got my 40 inwards there. This is my second point, so I'm going to go 40 millimeters inwards to find that point over there, and I'm going to go for this intersection point 40 inwards to find it, which are those points. Take my compass, the same dimension of what I've used for this circle. I'm just going to replace the sharp needle end to that point, and I will be basically drawing the arc from there up to this point over here. And then for this little circle over here, again I will use this last point over here, and then from there on the intersection points and the start position, 40 outwards, intersection point, start position, and I can complete the rest of the lines of what you see over there. Alright, but now there's a circle inside there, right, which is 35. So I need to find the center point of this and go 35 divided by 2. I have to go 17 to this side and 17 to the other side, upwards and downwards to find a block again. So there's my center point. It's bisecting point to bisecting, bisecting to bisecting. Principles of center lines, 20 millimeters, 4 millimeters gap, 4 line, 4 gap, and so it carries on. Always end with the long lines. Once the center lines is established, I can go 17.5 to either side and upwards and downwards to find my biggest possible block. Apply the principle, opposite sides, closest to each other, bisecting point there, and then from there on I can draw the circles in each arc on its own. And of course, if it's going to be of no use, I won't see the back circle at there, so therefore it's no use in going out into this direction. So that is the way you can determine, since this is round, you're going to do the center lines, and you're going to join the center lines with the needle point position of the circle itself. Alright, now ladies and gentlemen, this is where we are with this part over here. I have got this one over here for you. If you should take a look at this exercise over here, the question was, in this case, being given to you in this way. This is for grade 11, so you can expect drawings like this one over here where it's a bit more complicated. You can see the hexagon, so in other words you will immediately know that there's non-isometric lines, because you know with solid geometry that this corner will be 60 degrees and then that will be 60 degrees, so therefore you can't work on 60 degrees to find that drawing or that view over there. So you will have to a great extent, work with non-isometric lines in terms of finding those answers. There's a window there at the back, and there's the window at the back over there. This line running from left to right and running from left to right is basically the grooves that forms here on the bottom over here. You can see there's grooves over here and at the inside over there. And then I've got a slanted area here, 45 degrees, it's 30, so you should know 30 by 30 by 30 by 30 to get the 45-degree line. You don't need an auxiliary view in terms of that. So if we go to the answer, this is what it looks like. You can see the hexagon is on the top and it carries on the bottom over here. There's a gap. I always used to say, try to figure out how does it look like for you. It looks like a chair that you can sit over here with the flat end where you sit in there, and your back will be in this hollow area and that hollow area over there. And try to figure out how will it look like, and there's a small little window over there, and there's a step going up to the chair itself. So, and as long as you got the idea of what is going on here, then you can of course be able to work things out for yourself. But if you've got no idea, you have to start somewhere to get an idea of what's going on in terms of this view. There we go with the auxiliary view. You can see the auxiliary view has been framed. There we go with the frame of it. The hexagon has been drawn, and with that frame you get your marks for that. Of course, if you rub out this lines, obviously you're not going to get the marks. It's 1, 2, 3 full marks, so therefore it's 3 marks that you're going to lose out with this example over here. Like I said, it's not necessary for this because it's 30 by 30, so therefore this is not compulsory. The examiner will work things out in terms of if it's 100% correct, it will give you those 3 marks. But with auxiliary views, if it's not there, you won't be able to get your answer. Then another example I want to point out to you is this one over here. There you can see it's a circle. It has got non-isometric lines, and then of course the height is been given to you on this size, this area over here, but no dimension. Although this dimension, yes, it has got a dimension. It's 53 plus the 19 over there, so you can measure this one out. It's not a problem. There's no auxiliary view necessary for this part, but there will be an auxiliary view needed for the hexagon that you got over here at the back. And then of course you will have to do your isometric circle. The answer to this one is over here is it looks like this part over here, where this is a flat end over here. It's still going straight up there. There's no line over there, so there's no line over there. It's not a seam. And then from there on the hexagon that's been placed over here, if you look very close towards this portion over here, you can see there's the auxiliary lines over there, and of course the auxiliary view which was drawn on this part over here. Again, 3 marks for this. It can differ from drawing to drawing. And there's the construction for drawing the circle in there, biggest possible block, corners closest to each other, bisecting line, bisecting line, bisecting line, and bisecting line. And that was used as the intersection point to draw that arc, and this intersection for drawing that arc over there. Center lines, you get your marks for the center lines, and of course the complete drawing is all totaled up, and a mark out of 36 was given to this point. Very important, make S the lowest point, and the long and short of this part is work systematically from bottom upwards and try to figure out before you start drawing what does it look like for you, like a little car over here, a racing car with a big advertisement board on the left hand side, and then the guy will sit here inside the car with the wheels which is square on the side. So try to figure out what do you see, work from there on, and that's it. Ladies and gentlemen, thank you very much for joining. Thanks for listening. I hope and sincerely that you will understand the 2 principles: non-isometric lines, grade 10 work, isometric circles, grade 11 work. With grade 12 work, we will explain that to you next year if everything goes well. And I trust that you understand and I've got some insight in isometric drawings. And God bless. Thank you very much.